all, this is going to be a short video on how to do calculations involving mole relationships in balanced equations. So the first thing we're going to need here is an example of a balanced equation. So I'll use this one which we looked at in a previous video. Just want to remind you that if we're looking at this equation, then we have to specifically remember that coefficients in this equation represent moles, right? So we are talking about 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of NH3, right? Okay, so we're going to pick a couple of scenarios here. So the first one is I'm going to say that you're going to be given a quantity of 0.25 moles of N2, and what we want to know is if this is the amount of moles of N2 that you are given, then how many moles, we'll make that X, of H2 do we need, and how many moles, we'll call that Y, of NH3 do we need? Okay, so the key concept that we're going to be using here is the ratio of the coefficients. So if we take our moles of N2 and we convert that moles of N2 into moles of H2 by using the coefficient ratio of 3 moles of H2 over 1 mole of N2, then what we're using here is what is called a coefficient ratio. And that coefficient ratio will always be the ratio of the unknown over the given. And since in this case we knew we were given the N2, right? We knew that the N2 was the given, then in my first scenario here, I'm calculating moles of H2. So I'm going to use the coefficient of H2 as the numerator, that's my unknown, and 1 mole in N2 in the denominator. So of course when I multiply this through, I'm going to get an answer of 0.75 moles of H2. And then if I do the second part of the question, which is to calculate the moles of NH3, I'm going to once again start with my given piece of information, 0.25 moles of N2, and I'm going to multiply that by, once again, my coefficient ratio of unknown over given, but this time my ammonia, NH3, is my unknown, so I'm going to use a coefficient of 2 in the numerator, so that's going to be 2 moles of NH3, and 1 mole of N2 in the denominator. And of course that's going to give me 0.50 moles of NH3. Okay, so again, emphasizing that these two ratios right here that I'm using are what we call coefficient ratios. You might notice, by the way, that the moles of N2 and the moles of N2 cancel, and that the moles of N2 and the moles of N2 cancel. That's another way of sort of articulating the fact that the given coefficient must always be in the denominator there. Okay, so if we were to change this question to be something like the following, if I were to give you 32.8 moles of ammonia, and I would ask, okay, if we're going to make 32.8 moles of ammonia, then how many moles of H2 would I need to use? And how many moles of N2 would I need to use? All right, so what we're going to do here is, in order to calculate the moles of N2, I'm going to start with my given piece of information, which in this case is my 32.8 moles. And again, remember that this is moles of NH3. And what I'm going to do is I'm going to multiply by, one more time, the unknown over the given coefficient ratio. So my given is my ammonia, right? Let's just box that in and label that as the given. And so that means that I'm going to multiply by 1 mole of N2 over 2 moles of NH3. And of course, once again, my moles of NH3 and my moles of NH3 will cancel, and half of 32.8 is going to give me an answer of 16.4 moles of N2. And then if I do that kind of a calculation one more time to get my X, I'm going to be using the, sorry, just making some space there. I'm going to be using the 32.8 moles of NH3 once again, and I'm going to be multiplying in this case by the coefficient ratio of 3 moles of H2 over 1 mole, sorry, over 2 moles of NH3. Let me see if I can bring that equation back into view here for you guys. So there's my equation right there. I'll just bring it down here so that when we're working on the bottom part of the screen, we can see this. And so again, there's my reaction right there that I'm using. Getting back to the pen here, sorry. So there's my reaction that I'm using. And so remember that in this case, the given was the ammonia, and my unknowns were respectively N2 and H2. So in this calculation right here, my unknown over my given was the coefficient of 3, because that's what I was solving for. There's my unknown right there, over 2. Okay, and of course when I take 3/2 of 32.8, that's going to give me, via the calculator, 49.2 moles of H2. Okay, so hopefully that makes it a little more clear about what you do with coefficient ratios in the balanced equation. And that is the big takeaway, right? So please do remember and always use this unknown over the given coefficient ratio. Okay, thanks guys, that's it.